नमस्कार विद्यार्थी मित्रांनो, डेरिव्हेटिव्हज ऑफ कंपोजिट फंक्शन्सच्या अंडर येणारे जे एक्झाम्पल्स आहेत त्या एक्झाम्पल्स हा पुढचा व्हिडिओ बघूया. द एक्झाम्पल नंबर 5, द डिफरेंशिएट with respect to x. The function given is e raised to log x square minus log x square is a solution. Now, we have seen the exponential function and the logarithmic function in the 11th and the properties of logarithmic functions also. So one property of the logarithmic function here. A raised to log x to the base a is equals to x. Means whenever these two bases are same, this log and this base gets cancelled and then only x remains. So if we choose here the base instead of a, e, then it is e raised to log to the base e of x. So by this formula we get simply as x. And in the natural logarithm, the two types of logarithmic functions are there. Natural logarithm, which is when its base is e. This cannot be written. So e raised to log x is the x. So by this property, we can simplify this function. Then the e and log gets cancels to each other and only this function in the square bracket remains. So start. Let first this given function as a y. Y is equals to e raised to log of log x square minus log x square. By using this property, we can write next step. This is equals to e log gets cancelled, log x bracket square minus log of x square. Since a raised to log x to the base a is equals to x. Now see, these are the two different logarithmic composite functions. Here the square is taken of log x and its square. Here it is just x square, log of x square. So firstly, we differentiate this. As there is subtraction of two functions, we take the separate derivative of these two functions. Differentiating with respect to x on both sides. LHS dy by dx is equals to derivative of the two terms, log x square minus a derivative of log of x square. बघा इथं फक्त हा स्क्वेअर जो आहे तो ब्रॅकेट मध्ये आहे की ब्रॅकेटच्या आत आहे याच्यावरती याचं मीनिंग बदलते, त्यामुळे हे थोडंसं काळजीपूर्वक लक्षात घ्यावं लागेल. So firstly, the formula is applicable here. It is of fx raised to n. बघा, function raised to n, x raised to n चा फॉर्म्युला यूज करायचा आहे. त्याच्यामध्ये x च्या ठिकाणी log x रिप्लेस करू and then कंपोजिटच्या रूल नुसार f डॅश ऑफ x नी म्हणजे x च्या ठिकाणी जे रिप्लेस झालं त्याचं डेरिव्हेटिव्ह घेऊन इथे आपण मल्टिप्लाय करणार आहोत. सेम here fx raised to n into fx raised to n minus 1 into f dash of x. N is a 2. 2 into log x raised to 2 minus 1, that is 1. That is 2 log x into multiplied by taking the derivative of this fx, that is the derivative of log x, minus derivative of this term log of x square. So first it is logarithmic function. So derivative of log x is a 1 upon x. So instead of x, we are replacing here x square and multiplying by taking derivative of x square, d by dx of x square. So now in the next step, find the derivative of these two terms. These are the two simple functions now. 2 log x into derivative of log x is the 1 upon x minus 1 upon x square as it is, into derivative of x square is the 2x. 1x gets cancelled from here, and then the last answer will be 2 log x upon this x minus 2 upon x, that is the dy by dx here. पहा काय काय केलं आपण इथं. जस्ट एक रिव्हिजन घेऊ. प्रॉपर्टी जी आहे लॉगॅरिथमिकची त्याच्यानुसार ई लॉग कॅन्सल्स होत आहेत, देन आपलं स्क्वेअर ब्रॅकेट मधलं फंक्शन जे आहे ते सिम्प्लिफाईड फॉर्म मध्ये इथं आपल्याला मिळते. डिफरेंशिएट करतोय विथ रिस्पेक्ट टू एक्स. लॉग एक्स स्क्वेअरचा डेरिव्हेटिव्ह अँड लॉग एक्स स्क्वेअर या दोन्ही टर्म्सचा सेपरेट डेरिव्हेटिव्ह घेतोय आपण, ॲज इथे दोन फंक्शनची सबट्रॅक्शन आहे बाय द अल्जेब्रा ऑफ डेरिव्हेटिव्स. लॉग एक्स स्क्वेअरचा डेरिव्हेटिव्ह घेत असताना एफ एक्स रेस टू एनचा फॉर्म्युला यूज करतोय आपण. एन इंटू एफ एक्स रेस टू एन मायनस 1, 2 minus 1 is a 1 into multiplied by this f dash of x, म्हणजेच log x चा डेरिव्हेटिव्ह म्हणून मल्टिप्लाय करतोय. तीच केस इथे करतोय आपण log of x स्क्वेअर, लॉगॅरिथमिकचा डेरिव्हेटिव्ह 1 upon fx into f dash, 1 upon x square into derivative of x square, 1 upon x derivative, this is the 2x, this is the last term. See the next example. Sine of root of sine of root x. So the given function is the composite function. It is a combination of root function and sine function. So let's first the given as a y. Y is equal to sine of root x. विद्यार्थी मित्रांनो बघा, थोडंसं कंपोजिट फंक्शनचे डेरिव्हेटिव्ह घेताना आपण हे फंक्शन वाचतोय कसं त्याच्यावरून सुद्धा आपल्याला लक्षात येतं की फर्स्ट फॉर्म्युला कोणाचा यूज करायचा आहे. तर साइन ऑफ रूट म्हणजे पहिलं फंक्शन आपण काय रिडक्ट केलं, साइन, म्हणजे फॉर्म्युला जो यूज करायचा आहे तो कशासाठी, हे सगळं फंक्शन एफ एक्स स्ट्रेट करून साइन एफ एक्सचा फर्स्ट फॉर्म्युला. त्याच्यानंतर पुढं काय येईल, त्याच्यानंतर रूट ऑफ साइन रूट एक्स ही रिप्लेस झालेली टर्म, त्याचं डेरिव्हेटिव्ह घ्यायचं. मग आपण फर्स्ट इथं काय रिडक्ट करतोय, रूट ऑफ साइन मीन्स रूट एफ एक्स. आता नंतरचा चेंज झालेला हा काय असेल तुमचा एफ एक्स. रूट एफ एक्सचा डेरिव्हेटिव्ह अपॉन टू रूट एफ एक्स इंटू एफ डॅश ऑफ एक्स घ्यायचा आहे आणि मग तिकडे साइन रूट एक्सचा डेरिव्हेटिव्ह म्हणून मल्टिप्लाय करायचं आहे. साइन रूट एक्सचा डेरिव्हेटिव्ह येताना हा रूट एक्स फक्त आपला काय असेल एफ एक्स असेल. and then यावेळी आपल्याला composite functions चा derivative घ्यायचा. See how it is. Differentiating with respect to x on both sides. dy by dx is equal to dy by dx of this derivative of sin fx. Consider this as the fx in your mind and use the formula. Derivative of sin is the cos. Cos fx is the root of sin root x multiplied by taking the derivative of this replaced term, that is root of sin of root x. Now next step, first term as it is cos of root of sin of root x into derivative of this now root of sin means root fx. Now treat this sin root x as the fx in your mind and use the formula for root fx. The formula for root fx is the 1 upon 2 root fx. Fx is the sin root x into multiplied by f dash of x, that is derivative of fx, and is a sin root x. Next we take the derivative of this quantity only here. Next step, the first two terms as it is cos of root of sin of root x into 1 upon 2 root of sin of root x into derivative of sin root x, sin fx. So using the formula of sin fx, treating this as a fx now. He is now cos fx, that is cos of root x into multiplied by derivative of root x. In the next step, now it is a simple function root x. Take the derivative of this cos of root of sin of root x into 1 upon 2 root sin of root x into cos of root x as it is into derivative of root x, the 1 upon 2 root x, that is equals to this. We can write this in the simplified form. The cos of root of sin root x into cos root x divided by this 2 into 4 root x into root of sin root x. Final solution. बघा आणखी एकदा आपण काय केलं विद्यार्थी मित्रांनो, साइन ऑफ रूट. सो फर्स्टली या सगळ्याला आपण fx ट्रीट करतोय. जस्ट हे मनातच अज्यूम करायचं आहे हा fx आणि sin fx चा फॉर्म्युला. fx म्हणत असताना तेथे इथं आपण रिप्लेस करतोय. sin fx cos fx into f dash. f dash म्हणत असताना डिवाइड x नोटेशन घेतोय आपण, डिवाइड x ऑफ दिस. अगेन आता याचा डेरिव्हेटिव्ह घ्यायचा आपल्याला रूट fx. आत्ताचा जो fx आहे तो sin रूट x मीन्स 1 upon 2 रूट x into derivative of sin root x. Next step, derivative of sin root x is the cos root x into derivative of root x. Derivative of root x is the 1 upon 2 root x. Hence, next example, 1 plus 4x raised to 5 into 3 plus x minus x square raised to 8. So here it is the product of the two functions, two composite functions. These two composite functions are of the form fx raised to n, fx raised to n, and in the both the brackets the fx's are the polynomial functions. So firstly we use the product rule of the derivative, and then we use the derivative for the composite function. So what is the product rule of derivative? If u and v are the two functions, derivative of u and v is u into v is u into derivative v minus plus v into derivative u. So first function आपण as it is ठेवतोय, सेकंडचा डेरिव्हेटिव्ह घेतोय प्लस सेकंड टर्म मध्ये सेकंड फंक्शन ॲज इट इज ठेवतोय आणि फर्स्टचं डेरिव्हेटिव्ह हे सेम आपण इथं घेणार आहोत. सो याच्यासाठी मला हे टोटल फंक्शन काय घ्यावं लागेल, सपोज करावं लागेल u and v. So let us begin. So let y is equals to the given function 4x raised to 5 into 3 plus x minus x square raised to 8. Now differentiating with respect to x on both sides. dy by dx is equals to, by the product rule of the derivative, u as it is 1 plus 4x raised to 5 into derivative d by dx of v, that is 3 plus x minus x square raised to 8, plus v as it is 3 plus x minus x square raised to 8 multiplied by derivative first function 1 plus 4x raised to 5. So take the derivative of these two terms. 1 plus 4x raised to 5 as it is, derivative of this. Now let this term as a fx in your mind. Use the formula for fx raised to n here. Fx raised to n into fx raised to n minus 1 into f dash of x. The n is 8 into 3 plus x minus x square raised to fx raised to n minus 1, 8 minus 1, 7 multiplied by the derivative of fx, that is 3 plus x minus x square. Then second term 3 plus x minus x square raised to 8 as it is, into, for this use the same formula fx raised to n, 5 into 1 plus 4x raised to 5 minus 1 is the 4 into multiplied by derivative of this 1 plus 4x. Then it is 1 plus 4x raised to 5 as it is, in 8 also as it is, 3 plus x minus x square raised to 7 into derivative of 3 plus derivative of x minus derivative of x square. 3 constant, derivative of constant is the 0. 0 plus derivative of x is the 1 minus derivative of x square by the x raised to n formula minus 2x plus 3 plus x minus x square raised to 8 into 5 into 1 plus 4x raised to 4 as it is, into derivative of 1 0, derivative of 4x is the 4. Now write this in the simplified form. So it is 1 minus 2x, 8 into, so this will be 8 into 1 minus 2x into this 1 plus 4x raised to 5 into this 3 plus x minus x square raised to 7, the first term, plus the 5 into this 4, 20 into 1 plus 4x raised to 4 into 3 plus x minus x square raised to 8. is the final solution. dy by dx is equals to. See once again, derivative of u into v, product rule of the derivative. So by using this, u as it is, derivative of v is taken, v as it is, derivative of u is taken. Next, for the derivative of this term, let the bracket as fx raised to n formula. Then again here it is written that this as the fx raised to n, the formula of fx raised to n. Now derivative of this is here, derivative of 1 plus 4x is here in the simplified answer. See one more example. E raised to 2x minus e raised to minus 2x upon e raised to 2x plus e raised to minus 2x. So here it is an exponential function. The change you can see here it is plus 2x and minus 2x plus 2x minus 2x. We know that the minus power, negative power, turns positive in the denominator. So we can do this. And then by cross multiplication, the denominator will get some cancelled. So we can use directly the quotient rule of the derivative. Let this numerator as a u, denominator as a v. Just recall the quotient rule of the derivative. That is, whenever the division of the two function is given, u upon v is given, then its derivative is given by v into derivative of u minus u into derivative of v divided by v square. See the quotient rule acts like product rule, only the change is here minus, and here the first term is v. So we are simplifying for this. Let y is equal to e raised to 2x minus e raised to minus 2x upon plus e raised to minus 2x. Then 2x minus, this will be positive in the denominator, e raised to 2x minus e raised to 2x plus 1 upon e raised to 2x. Then we take the cross multiplication in the numerator also and in the denominator. Then e raised to 2x into e raised to 2x, e raised to 2x square, that is 2 into 2 is 4, 4x, e raised to 4x minus this one divided by e raised to 2x divided by, same is here, only plus, e raised to 4x plus 1 upon e raised to 2x. This common denominator gets cancelled and the simplified function is e raised to 4x minus 1 upon e raised to 4x plus 1. This is our y now. Now differentiating by this rule. Differentiating with respect to x, we get v and u. This numerator is u, denominator is the v. By using this formula, we get dy by dx here v e raised to 4x plus 1 into derivative of the numerator e raised to 4x minus 1 minus u e raised to 4x minus 1 into derivative of e raised to 4x plus 1 divided by v square, means denominator square. The denominator is e raised to 4x plus 1, it's a square. So we solve the derivative terms here, derivative of these two terms. e raised to 4x plus 1 as it is into derivative of e raised to 4x e raised to fx e raised to fx into f dash of x e raised to 4x as it is multiplied by derivative of 4x minus the derivative of one constant, so 0, minus e raised to 4x minus 1 into, again by the same, derivative of e raised to 4x e raised to 4x into multiplied by derivative of 4x and my plus derivative of 1 is a 0 divided by e raised to 4x plus 1 bracket square as it is. This is equals to e raised to 4x plus 1 into derivative of 4x for constant derivative of x is the 1. 4 into 1 is the 4. So is the 4 into e raised to 4x minus e raised to 4x minus 1 as it is into, again the same is here, 4 into e raised to 4x divided by e raised to 4x plus 1 bracket square. So now this is the answer, but we can simplify this. The 4 into e raised to 4x can be taken outside. So 4 into e raised to 4x into, within the bracket these two terms are here, e raised to 4x plus 1 minus of this is minus e raised to 4x minus minus plus 1 divided by denominator as it is e raised to 4x plus 1 bracket square, then the plus e raised to 4x minus e raised to 4x gets cancelled, then 1 and plus 1 is the 2, so 2 into this 4 is a 8, 8 into e raised to 4x divided by e raised to 4x plus 1 square is the final answer of this function. काय काय केले आपण e raised to minus 2x घातांकाच्या नियमानुसार हा 1 upon e raised to 2x, त्याच्यानंतर इथं आपण तिरकस गुणाकार घेतो क्रॉस मल्टिप्लिकेशन, त्यानुसार here e raised to 4x means e raised to 2x into e raised to 2x, e raised to 4x cancels the simplified function. आता याला आपण u and v ट्रीट करतोय आणि quotient rule of the derivative यूज करतोय. Quotient rule of the derivative of this term, same here, the simplified answer. Okay. See one more example. Log of root of 1 minus sin x upon 1 plus sin x. So let first this as the y is equals to log of root of 1 minus sin x upon 1 plus sin x. लॉगरिथमिकच्या प्रॉपर्टीज आपण इथे यूज करू शकतो लॉग m upon n च्या फॉर्म मध्ये, पण परत ते कॉम्प्लिकेटेड आहे. पण ट्रिग्नोमेट्रीच्या अर्थ इथं आली आहे, आपण या टाइप मध्ये फंक्शन जर असेल तर हे सिम्प्लिफाय करू शकतो. अशी भरपूर एक्झाम्पल्स आपल्याकडे आहेत डेरिव्हेटिव्स मध्ये, इंटिग्रेशन्स मध्ये, ट्रिग्नोमेट्रिक फंक्शन्स मध्ये. लास्ट इयर सुद्धा आपण हे एक्झाम्पल सिम्प्लिफाय केलेला आहे. तर ही टर्म रूट ऑफ आपण सिम्प्लिफाय करू शकतो. मग त्याच्यासाठी काय करता येईल? देयर आर टू मेथड्स आर हियर. फर्स्ट in which the sine is converted into cos, and then the formula for 1 minus cos and 1 plus cos is used. And then the root will get some cancelled. आता हे सिम्प्लिफिकेशन मीन्स कशासाठी असणार आहे, तर या एक्झाम्पल मधलं रूट त्या सिम्प्लिफिकेशन नंतर कॅन्सल होईल. रूट केव्हा कॅन्सल होईल, जेव्हा विदिन द रूट आपली जी टर्म आहे इनसाइड द रूट ती स्क्वेअर क्वांटिटी असेल तर स्क्वेअर अँड रूट कॅन्सल होतील. म्हणजे या आतल्या टर्म्स ज्या आहेत 1 मायनस साइन एक्स अपॉन 1 प्लस साइन एक्स त्या स्क्वेअर फॉर्ममध्ये आल्या पाहिजे. त्या स्क्वेअर फॉर्ममध्ये यायच्या असतील तर आपल्याला मी जर इथं न्यूमरेटरला 1 मायनस साइन एक्सने मल्टिप्लाय केलं तर हे 1 मायनस साइन एक्सचं ब्रॅकेट स्क्वेअर मीन्स स्क्वेअर अँड रूट कॅन्सल होईल. आणि मग मी न्यूमरेटरला 1 मायनस साइन एक्सने मल्टिप्लाय करते तर डिनॉमिनेटरला सुद्धा सेम करावं लागेल. जर मी इथं डिनॉमिनेटरला 1 मायनस साइन एक्सने मल्टिप्लाय केलं तर हा ब्रॅकेट स्क्वेअर न मिळता आपल्याला ए प्लस बी इंटू ए मायनस बीचा फॉर्म मिळेल. अँड देन ए स्क्वेअर मायनस बी स्क्वेअर यूज केला 1 मायनस साइन स्क्वेअर कॉस स्क्वेअर मिळेल आणि अगेन रूट कॅन्सल होईल. बघा काय काय होते आता. So we are multiplying by the term 1 minus sin x inside the root and dividing by the same by 1 minus sin x in the root. Therefore this will be 1 minus sin x into 1 minus sin x 1 minus sin x bracket square divided by a plus b, a minus b. It is a square minus b square, so 1 square 1 minus sin square x. So now this will be log of root of 1 minus sin x bracket square, and by the identity we get this as a cos square x, and then root will get cancelled. Now this it is only 1 minus sin x upon cos x. And now we can use the log fx formula, but this term is again simplified. You can simplify it again. This is 1 upon cos x sin upon cos x. This sec x minus tan x. And this quotient can be converted into the subtraction easily. So we do this. So this will be log of 1 upon cos is the sec x, sin upon cos is the tan x, sec x minus tan x, and then we differentiate this. So differentiating with respect to x on both sides, dy by dx is equals to, so use the formula of log fx. Treat this as the fx in your mind and use the formula derivative log x 1 upon x. So 1 upon fx, that is 1 upon sec x minus tan x into derivative of sec x minus tan x, then sec x minus tan x as it is into derivative of sec x minus derivative of tan x. Derivative of sec x is the sec x into tan x minus the derivative of tan x sec square x. This can be simplified here in the next step. Sec x minus tan x as it is. We can see here one sec x is common here. See, if we take sec x common, then this term will be tan x minus sec x. And the change is only here. First term is the sec x and second term is the tan x. So we take minus sign also outside here. Then this will be the sec x minus tan x. So minus sec x are taken common from the two terms. Then this will be minus tan x and this is the plus sec x. So sec x minus tan x. Now this will get cancelled the same bracket, and the simplified answer of this derivative is dy by dx is equal to मायनस सेक एक्स. पहा काय काय केलं आणखीन एकदा. रूट फंक्शन आपण सिम्प्लिफाय करण्यासाठी काय करतो, तर जेव्हा केव्हा या टाईपमध्ये फंक्शन्स येतील तेव्हा आपण या वेळी इथं असं मल्टिप्लाय करतोय न्यूमरेटर डिनॉमिनेटर. 1 मायनस साइन एक्स स्क्वेअर मिळेल आणि ए प्लस बी ए मायनस बीचा फॉर्म्युला अप्लाय केल्यानंतर 1 मायनस साइन स्क्वेअर मिळेल. म्हणजेच काय असेल, आयडेंटिटीनुसार कॉस स्क्वेअर असेल. तर हे रूट स्क्वेअर कॅन्सल्स होतील. याला आपण 1 अपॉन कॉस अँड साइन अपॉन कॉस केल्यानंतर हे सेक मायनस टॅन मिळेल. आणि आता आपण डिफरन्शिएट करतोय ही टर्म एफ एक्स कन्सिडर करून लॉग एफ एक्सचा फॉर्म्युला यूज करतोय. तर हा फॉर्म्युला डेरिव्हेटिव्ह ऑफ सेक डेरिव्हेटिव्ह ऑफ टॅन, देन आपण इथं मायनस सेक कॉमन काढतोय. ही मायनस काढल्यामुळे काय होईल, ओनली सेक काढला की टॅन मायनस सेक मिळेल. तो कॅन्सल आउट करताना इथे थोडीशी अडचण येईल. तर मायनस काढल्यानंतर आपल्याला ते सेम मिळेल उलटून. कॅन्सल अँड मायनस सेक एक्स. ओके, थँक्यू.